let's see what is the difference between supervised and unsupervised learning. So like again, in this course, we actually you learn two types of learning method. Like we're gonna learn the second one today, the supervised and unsupervised. And when I say supervised learning, it means like we observe both set of features for each object as well as a response or outcome variable y. So in our data matrix, let's say we have this table or data set data for our analysis. So in the supervised learning setting, we have the features, like let's say in this case, we have P features, and we have also a target variable, like response or outcome variable, which is denoted as Y. But in the unsupervised learning, we don't have that target variable. We observe only the features. So we have P features. So we're not interested in prediction because we don't have an associated response variable in our data set. Okay? This is the main difference between supervised and unsupervised learning. Now, in unsupervised learning, the goal is to discover interesting things about the measurements. But when I say measurements, I mean the features for each observation. So like for example, like is there an informative way to visualize the data? Like can we discover subgroups among the variables or among the observations? Okay, so there are two common techniques used for in unsupervised learning, as I mentioned here, like clustering and principal component analysis. The principal component analysis is a tool that is usually used for data visualization or data pre-processing before supervised techniques are applied. Technically, what I mean is, rather than let's say imagine you have like many features in your data set, rather than using all of them, we can just focus some of them, and that sum will describe the majority of the variance in our data set. And in the clustering, the other technique or problem is a broad class of methods for discovering unknown subgroups in a data set. And this is the one that we're going to learn today mainly. So let's see an example for clustering. So let's say like a grocery retailer uses clustering to segment its, let's say 1.3 million loyalty card customers into 5 different groups based on their buying behavior. So then using that results, it then adopted like the retailer can adopt like customized marketing strategies for each of these segments in order to target them more effectively. So rather than like using the same strategy for all the loyalty card customers, we can cluster them into segments, and for each segment, based on their like descriptions or based on their style, we can customize like marketing strategies for each segment. Now, in clustering, again, there are many techniques that we can use. K-means clustering, hierarchical clustering, DB scan, and so on. Today, I'm going to talk about like K-means clustering and hierarchical clustering. So let's start with K-means clustering. But before I start, do you have any questions about the difference between supervised and unsupervised learning? Is that clear, the difference? I don't see any questions, so I'm gonna take that as yes. Okay, let's start with K-means. So K-means clustering is one of the techniques that we can use. So the goal is to seek partition of observations into a pre-specified, that's the important part, pre-specified number of clusters so that the observations within each group are quite similar to each other. Now, in general, let me use this whiteboard again. In general, the idea of clustering is this. So let's say we have a data set. Let's say we are talking about a like 2-dimensional data set. Okay, we have only two features. And each circle represents an observation. Okay, and let's say when I plot this data, let's see, can you elaborate regression versus association, like unsupervised causing counting literature, people regress stuffs and say we see association. Okay, that's a great question. So that is different than this association analysis, okay? Like this is called like association rule. For example, let me give you an example. Like let's say you're working on a big like retailer, and what you want to do is you want to like organize the shelves in a way that the customers can find the related items easily. Okay, how do you do that? One thing, like one possible approach is you can look at all transactions, and in transactions, look, let's say like for each transaction, let's say a customer comes to retail store and you look at like what that customer bought together. Okay, and you look at that information over all customers, and then you can see, let's say item X and item Y is co-purchased more like frequently. That means like you can put those two items close to each other when you organize your shelves. So that is called like association rule. So like the term that you are talking about, like saying association is different than this association analysis. Okay, like when you say when you use that association term in regression, like you're just saying that, let's say like this X variable is affecting, let's say the size of the house is, there's an association between the size of the house and price of the house. Technically, you're saying that the size of the house is affecting the price of the house. In that case, price is your dependent variable and the size is one of your independent variable. Okay. Does that answer your question? Okay.